Welcome back, my dear friends and students. As you know, it's a very good morning, good afternoon, good evening, wherever you are, and you are listening to this course and taking the part in this course. You know, this is the DADM 2, which is Data Analysis and Decision Making 2 under the NPTEL MOOC series, and the total number of hours is 30. So, which is basically 60 lectures, because each lecture is a half an hour and it is spread over, total course is spread over 12 weeks. And each week we have 5 lectures, after each week we have assignments, and we are in the last lecture for the 7th week, which is, as you can see in the slide, is the 35th lecture, and this course is under the NPTEL MOOC series. And my name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. And if you remember, we are discussing about the TOPSIS, and we have just started by considering that there are 11 parameters or criteria based on which a person is planning to buy a house. Houses are given as A1, A2, A3, A4 are the alternatives, and the criteria, those 11 one are from C1 to C11. And if you remember, we have those points or the criteria matrix for each and every alternative. So, these are not normalized, we will normalize them accordingly. So, consider that we normalize them, and what normalization we are using. If you look this, let us look at these two blue points. So, this is 0.5964 and 0.6471. So, if you go back to the last class, the slides, so they were basically being normalized. You can use the concept of either the column or the row. So, I am basically doing it along the row. So, the first value was 40, 40 square, 42.9 square, 62.5 square, 6.8 square, 1.3 square, 0.8 square, 0 square, 1.2 square, 1.8 square, 4.2 square, 2.2 square. So, from where did these values come? Look at R 3, 2. So, this is the space for the 3, 2 cell, that means I am considering the third alternative and the second row. So, the second row values were this, which I said at the squares. Now, okay, my mistake, it would be basically the third row, my mistake, sorry, because 3 is basically the third alternative, and 2 was basically the cell value, which was 42.9, which is here. I will just mark it. I'll use a different marker here, so it will be easy. Sorry for that. So, this is yellow, this is yellow, this is orange, this is orange. So, it will be easy for us to find out. Then the value of 3, 2 would be given. So, if it is 3, 2, so 42.9, 42.9. So, I calculate these values. When I go to 4, 8, again I will consider the 8th column and the 4th row. Row means the 4th alternative. The values are given 41.7. I am not mentioning the square values. 25, 78, 7.8, 10.6, 2.3, 1.8, 1.9, 3, 3.2, 3.8, 1.3. So, these are the accrued values which are coming from each and every criteria to each and every alternative. 11 criteria, 4 alternatives. So, the third value is basically coming from the sense I am considering the 8th column. So, let me see what is the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. So, this is 3 is 8. I will use a different color. Let me use the light green, 3 with 3 here. So, with this you calculate all the values. Best would be just put it in the Excel sheet and calculate. So, once you have this, now I consider the weights. So, the weights are, I am for this problem I am considering for each and every criteria starting from 1 to the 11th one are I am only reading the 2 places of decimal 0.11, 0.10, which is about 11%, 10%, the third one is again 11%, fourth one is 9%, 11%, 6%, 6%, 11%, 9%, 6%, 5%. So, that means what is the weightages for each and every criteria amongst themselves. So, double check, the sum should be 1 as it is. Now, what I will do is that I'll now, given the normalized matrix which is R, capital R, and I have already explained how the normalization was done, whether the rows or the columns are being used. You can interchange them, there is no issues, but remember the R matrix which will be multiplied by W is of size m cross n, which is 4 cross 11 here, and the size of the matrix which is W would be 11 cross 11. So, this is the value. So, once I multiply them, I am not going to this was not possible in a one slide. So, I have given the actual value of V, which is V is equal to, if you remember, I will again write, I am sure you remember, but still for the sake. So, V was basically 4 cross 11 was being calculated from R, which is 4 cross 11 into W, which was 11 cross 11. So, the value of V is given here. Now, if I want to find out each and every cell value, so I have only highlighted, again use the blue color, no, I will not use the blue color, yellow would be better. So, I will basically highlight this value which is here. So, how did I calculate? I took, this is V211, which means I am taking the second alternative and the 11th criteria, that means the second row and the 11th column. So, the values are given. So, this 0.5622, 0.4629 and so on and so forth till the last one, which is 0.37, were already calculated normalized values for the vector R, or the matrix R. So, that you multiplied with the last column for the weight. If you remember, the last value was 0.058, which is about 5% weightage being given to the 11th criteria. So, all the other cells were with 0. So, if you multiply, the value comes out to be 0.0215. So, based on that, you have the matrix V. Now, given matrix V, now our actual calculation will start. So, let us pause here. The V values gives us the weightages which are corresponding to each and every criteria, and the normalized overall accrued value which is coming out from each and every criteria on each and every alternatives. That means, they are normalized on a scale of 100 or 1, that means, on a scale 1, what is the value which each criteria is giving to each alternative, that was 1. Then we multiplied by the weightage corresponding to the fact that the weightage would give you the importance level among the criteria themselves. So, once I multiply, I am merging both these two concepts. One is the weightages among the criteria, and one is the valued accrued from each criteria to the each alternative. So, now I have so called made a ranking corresponding to the fact of the criteria and the alternatives. Now, this V matrix would be utilized. Now, if you remember, I have to find out the V plus values and the V minus values for each and every these concepts of the columns which are the criteria. So, if you are normal, remember one thing which I did not mention in the last lecture, for which I apologize. So, when you are trying to find out the V plus or the V minus, remember in which direction you are doing the normalization. If it is along the rows, so you will find out the V plus for the rows. If you are doing along the columns, you will find out the V plus for the columns. Similarly, for the V minus. So, here we did normalization corresponding the fact for each row was taken, because there were 11 elements in the denominator, 11 elements squared and thing being added, and then find out the square root. So, if I have this, I try to find out the maximum. So, I give you two only examples to make you understand. So, let me again highlight it. So, I highlight the first value with the first value, I highlight the second value with the second value. So, what was 0.669? If I take the maximum of all the values which were there corresponding to the fact. So, I have, say for example, for the first this alternative, I have 11 values. They are starting from 0.0609 till the value of 0.055. So, I am taking the maximum that for each and alternative. So, the maximum is coming out to 0.0669. Similarly, go to V2 plus, it is the maximum for all these 4 values. So, you have to consider the columns. So, there are basically 4 values in each column. So, first column which is criteria 1, 4 alternatives, second column second criteria 4 alternatives. Once you find out, you will have basically such 11 values and each being the maximum of the 4 values. Remember that, because that can be reversed depending on the concept of the normalization you are utilizing. Similarly, I go to the V minus. Here in the V minus, I take the minimum. Remember that max minimum is coming. So, when I do that, I try to find out the V min, and the V min values. Again, what I am doing is that I am again taking one column at a time, and in each column there are 4 values. So, the 4 values are corresponding to alternative 1, 2, 3, 4, and how many columns are there? There are 11. That means, for each criteria I rank the alternatives amongst each other on the weighted scale. What is the weighted scale? Again I am repeating, that was the multiplication of the R matrix with each and every row for the R matrix with the columns of the W matrix, corresponding to the fact that R was the normalized values accruing from each and every criteria to each and every alternatives, point 1, and point number 2 was that the weights gave us the level of importance among the criteria themselves. So, once you have this, the VI values are given which are minimum. So, again I will color it in for ease of understanding. This is the first value, gives us the first value, the second value gives us the second value. Similarly, the third, fourth and so on and so forth can be found out. So, they would be technically V1 to Vn. I am not talking about the minus sign, because it will be plus for the positive values. So, V1 to Vn basically will have such 11 values. Now, once you have that, you want to basically find out the distance of each project, or each or project means the alternatives, to the most positive ideal solution. Similarly, you try to find out the distance of each of alternatives from the most negative ideal solution. So, once you do that, I have the same formula for S plus, it will be the difference of the distance. Now, here you see, this is basically the concept which is coming is the distance is basically the L2 norm, which is the Euclidean distance which you have talked about. It can be changed depending on what type of problem you are trying to do. So, it will be the difference between each and every cell value with the maximum to find out the most positive ideal solution, square it, sum it up and find out the square root, such that you are giving one criteria for the S1 plus, which comes out to be 0.1045. If you do the calculations, you can find out. So, if there are Vj plus, Vj's would basically be for each and every rows we had the maximum values. So, if you find it out, the values are coming out to be 0.1045 and highlight them. This once I am requesting you, once you have that matrix, remember that I am again going slowly. Once you have the matrix for the value of x, normalize it, be careful what normalization you are using, also be careful what is the normalization you are using in which direction, row or column. Once you do that, have a understanding that what is the weights. Remember, the size of x should be m cross n, size of value of r, which is a normalized matrix corresponding to the fact that you are getting it from x, also should be m cross n. M is the number of alternatives, n is the number of criteria. Similarly, the weight matrix would be n cross n. So, once you find out S, or once you want to find out V, which is a matrix, would be size m cross n multiplied by n cross n, which is m cross n. Once you have that, you basically find out the positive value, which is the ideal solution, negative value, which is the ideal solution, but these being from the positive sense and the negative sense. So, once you have that, you will basically find out the values of V pluses values, which are the max for the positive sense, and V minus would be the min from the negative sense. And then I also mentioned that you can find out the mean for the max also, and mean for the not for the max, mean for the positive distance and max for the negative distance. So, once you have that, you find out the most positive ideal solution and most negative ideal solutions, which are given as this. I will use the color scheme as Si plus is given, S1 plus is given, S2 plus is given, which is for the first and the second alternative. Similarly, S3 plus for the third alternative and S4 plus for the fourth alternative. So, remember this color scheme: orange, yellow, green, blue. I will come to that within few minutes. So, now I do the most negative solution. So, negative solutions, I already have the V minuses, which is here. I am not going to mark it. So, once I find out the V minuses, again I find out the difference of the distance, square them up, sum them up, find out the square root. Again I am trying to follow the L2 norm. So, once I have them, I basically have the S1 minus, S2 minus, S3 minus, S4 minus in the negative sense, the negative ideal solutions or distances for the first, second, third, fourth alternative. So, let them mark that orange for the first, as I did for Si plus, yellow for the second, as I did for the S2 plus, green for the third, as I did for the S3 plus, blue for the fourth, as I did for the S4 plus. So, there is a reason for that why I am doing that. So, you have found out Si plus values 1, 2, 3, 4 for 4 alternatives. I found out Si minus for 1, 2, 3, 4 values, 4 alternatives. These are basically the maximum and the minimum distance corresponding to the fact that I am using the concept of ideal distance, how far or how close it is. Now, you want to find out the relative proximity. So, on the relative proximity index for each and every alternative would be how close or far it is on a scaled value. So, the scale value. Now, if here again I repeated one thing I did mention and did draw that in the last class, which I will try to again highlight it here on once again. So, I find out the relative proximity of index for each alternative, which is that buying of that house, to the ideal solution. So, what is the ideal solution? Whatever I have found, we will find out how close or far it is, and I will basically try to rank them accordingly. So, I am only taking, if you remember, I mentioned 4 columns. That means, for the max case for the positive, min case for the positive, then I do it for the mean case for the negative and max case for the positive. So, now again listen to me carefully. Max case for the positive means closer the distance is better, that means it is absolutely essential that I am at that point of the ideal solution. So, higher it is good. Now, if I go to the second column, what I have said, I was basically mean of the distances. So, when I am taking the mean of the distances is basically I am going as far as away from the positive solution. That means, it is positive, but I am slowly trying to go away such that it will not accrue to me that higher value. When I go to the third column concept is basically mean of the negative values, that means how far I am with respect to the negative solution. So, if you take the first and the third column, if both the values are high in the sense max value high, mean value be as low as possible, that is the best combination. That means, it is a win-win situation in both the cases. I am winning, that means in the first case, that means I am closer to the positive solution, and it is mean for the third column, which is I am as far as away from the negative solution. The worst case scenario is the second column and the fourth column, that means I am minimum from the I am as far as away from the positive solution, and I am as close as possible to the negative solutions, which is the worst case. and the other two cases which are the combination for the first and the third, and first and say for example the fourth, and the second and the third would give me a combination which I have to basically rank. So, these things I am not included, but I am again repeating it not to make it too much complicated. So, you have the solution. So, I have basically C1, C2, C3, C4. So, these S values were already given. So, if you remember this, I'll highlight it. Now, let me do the writing again. So, whatever I have said, if I write it down, it will be easy for us to understand. So, there were again 4 columns which I mentioned. So, let me mention them as positive solution, negative ideal solution. So, this is the column where I have divided them into 2 parts. Then under each I divide into 2 parts. What are these? So, let me talk. When I use the positive solution, I am using a max. When I am using the negative, I am using a min. I am using the same color scheme, remember. When I use the min for the PS, I use the light green, and when I use the max for the NIS, I use the dark red color. Now, all these things would give me the combinations. Combinations are, there are 1, 2 here and there are 2 each here. So, there will be 4. So, I am only using one of them. I can do the relative ranking and give a much better picture. Some would be very difficult to differentiate, because if you take the first and the say for example, the first and the first here, that means first and the third would give you the best solution. Second and the fourth will give you the worst solution. Any combination of first with respect to say for example, fourth, and considering second with respect to third will give me an intermediate solution. So, what I am trying to do is that here what is coming out here is this one. So, I will mention it as first A, first B, second A, second B. So, the combinations can be done accordingly. The values of C1, C2, C3, okay, this should be C4, sorry for that, and I will change it here. So, the values are coming out to be as it is given. Just pay attention here. So, C1 is 0.36, I am only reading the 2 decimals. C2 is 0.23, C3 is 0.30, C4 is 0.68. Once you have that, you can find out the values corresponding to that. Now, once you are done, the ranking values would give that when you rank this C1, C2, C3, C4 corresponding the max for the positive and mean for the negative, then you have C4 is better than C1, is better than C3, which is better than C2. Hence, it will mean the alternative 4 is the best, which is in position 1. That is the house where you are trying to buy, depending on the 11 criterias. Alternative 1 is the second one, which is second position. Alternative 3 is in the third position, third one, and finally, alternate 2 would be in the position 4. Now, the ranking which you have used, now this is the simple step which I followed for the problem. Ranking which you have used was for max min, again I am repeating, that means first and third. Similarly, I can get 3 different other ranking system based on the second and the fourth, which is also quite easy to understand. The things would basically be difficult to make a judgment would be the case when I am considering the second and the third, and when I am considering basically the first and the fourth, based on that one I am doing. So, with this I'll end the Topseed method discussion, and this is the end of the 7th week, which is the 34th, 5th lecture, and you will only have assignments based on the concept of Topseed. And from next week, which is the 8th, we will start the other different multi-criteria decision making, and hope any queries which you have, you can basically put in the forum, and we will definitely try to answer, the TAs would definitely try to answer as soon as possible. Have a nice day, and thank you very much for your attention.